Okay, so we're starting our unit on proportions and proportional reasoning and ratio rates. And we're going to look at our first problem, which is Harry. He's walking, and they tell us that he can walk 2 feet in 1 second. So we're going to fill out this chart. In 1 second, he walks 2 feet. So our process is 2 times 1. So each one, every time we have a time, we just multiply that by 2, and that gives us how far he walks. So let's fill in the rest of our chart. If you need to pause to catch up, I will be moving kind of quickly, just so we can get through this. So 2 feet, 2 times 2 is 4. 2 times 3, 6. 2 times 4, 8. 2 times 6 is 12. 2 times 8 is 16. On this one, we have to actually work backwards. We know that 16 is our distance. What divided by 2 is 16, and that would be 8. 10, 2 times 10 is 20. 14, 2 times 14 is 28. Again, on 40, we have to work backwards. What divided by 2 is 40, and that would be 20. So 2 times 20 is 20. Our process is 2x. So whatever our x is, time, we put that in, we multiply by 2, and that gives us our y. Now this column is going to be our x's, this column is going to be our y's. We're going to graph it on our graph over here. So 1, 2, so we're going to have a linear graph here. Let me jump to 6. And then we have 7, 8, and 16, 10, and 20. And our next one would be 14, 28, which is off our chart. It would be somewhere up there. But as you can see, we have a linear graph. So on number 1, it's just asking us questions on our graph that we've already figured out. How far did he go in 1 second? 2 feet. 2, 4 feet. 6, 12 feet. 10, 20 feet. How far did he walk in 14 seconds? 28 feet. How long did it take him to walk 16 feet? So we go up here, we find 16, and it was 8 seconds. How long will it take for him to walk 40 feet? And that would be 20 seconds. And so we're going to write our unit rate as it compares distance in feet and time. In seconds, that like Harry walks in 1 second, and he walks 2 feet per second. And that's and so now down here, we're going to set this up as a proportion. We did it as a multiplication at the top, and now we're going to set it up as a proportion. We're going to figure out how far it takes him to walk 16 feet if he walks 2 feet in 1 second. Now, whenever you set up your proportions, notice they're fractions. We're going to do equivalent fractions. So we know that he walks 2 feet per second. So, and then we put seconds over here. I'm sorry, feet over here, so 16. So what do we multiply 2 by to get 16? We multiply that by 8. So if you multiply your numerator by something, you multiply your denominator by the same thing. And so we keep our fractions equivalent, and that's how we figure out he goes 8 in 8 seconds. It takes him 8 seconds to travel 16 feet. So now we want to write a proportion showing the unit rate to find how long it will take him to walk, how far he walks in 57 seconds. So we have 2 feet per second equals, we don't know how many feet. We're going to leave that blank. We do know it's 57 seconds. So we multiply 1 second, 1 times 57 to get 57. So we're going to multiply 2 times 57. And we get 114 feet. We just keep our fractions equivalent. So we want to write an equation. We just look at our 2x. They tell us where d is equal to, t is the time. So 2 times t. That's our equation. And look back up at our equation up here at the top, 2x, our process. It's the same. It's the same as 2x. What? The variables are different. So it's the same. So now we're going to go over to the back, and we're doing more proportional ratios. So on the first one, it asks us if we know that you go 5 miles in 2 hours, can you use a proportion to figure out, or can you figure out how far you would go, how long it would take you to go 15 miles? How many hours? So we set up our proportion. What do we multiply 5 by to get 15? 3. So we're going to multiply 2 times 3 and get 6. It takes 6 hours. Now remember, the most important thing you remember when you're setting up proportions is you're comparing miles over hours and miles over hours. Your top 2 need to be the same and your bottom 2 need to be the same. If the top one's distance, both of them need to be distance. The bottom's hours or time, both of the bottom they both have to be time. So now on the next one, Avery, he can mow 1.75 lawns. This is just given information in 1 hour. So that would be our proportion for how long he can mow, how many lawns he can mow in an hour. So we're going to go down here. If he mowed 7 lawns in 4 hours, how long will it take him to mow 21? And then it says, how did you write a proportion? Let's do the proportion down here. And we have 7 lawns in 4 hours. How long will it take him to mow 21 lawns? And we're looking for this time there. So 7 times 3 is 21. If you do it, multiply the denominator, you have to multiply, the numerator, you have to multiply the denominator. 4 times 3 is 12. It takes him 12 hours to mow 21 lawns. Of course, assuming the lawns are the same size. What factor of change did you multiply by the unit rate to find the number of hours it took Avery to mow 21 lawns? This was our factor of change. And so it was 3 was our factor of change. Write a unit that compares the amount of money Annie will pay for each container of hummus. So here's our problem down here. We have okay, how did you write the proportion? Let's go down here to write the proportion for our hummus. It tells us $3 for 2 containers. $3 for 2 containers, and she has $12 to spend. How many containers can she buy? So 3 times 4 is 12. 2 times 4 is 8. She can buy 8 containers. And the containers, you could use 3/2, or you could use $1.50 over 1 container. Both of those are correct. Whichever one is easier for you to use. And our last one is, what was our rate of change? What did we multiply by to get our new proportion? Our rate of change was 4. So I hope that makes sense. If you have any questions, please come to tutoring, and I will see you in class.